Now let's look at systems of linear equations when you have three variables and three equations. So here's an example problem. We have 3x plus y plus z is 14, etc., minus x plus 2y. Now if you notice here, you have three equations and you have three different variables. So the first thing is we have to think about what the steps are. We're going to use what's called the elimination method, and it's very much like the elimination method with two variables. So let's go over the steps of the elimination method. The first thing that we're going to do is we're going to use two equations, and we're going to eliminate a variable. And then after we do that, we're going to use two equations, and we're going to eliminate the same variable. And what I mean by the same variable is the same variable that we eliminated in step number one. Now the trick here is that when you do these two steps, you have to use all three equations. So for example, whatever two equations you used in the first step, in the second step you have to use that third equation as well. After we do that, what we'll notice is we simply have a system of linear equation with two unknowns. So we're going to use the answers from step number 1 and 2. And we're going to simply solve. And then the fourth step is we're going to use the answer from step number 3. To plug in, and then we're going to solve there. So I think that'll become clear as we start going on, but we'll review back to this. So let's take this equation. So what I'm going to do is I'm going to first take these first two equations, and what I'm going to do is I'm going to eliminate the y. And the way that I'm going to do that is I'm going to multiply the second equation, I'm going to multiply the first equation by a minus 2. So then I get minus 6x minus 2y minus 2z is equal to minus 28. And then I get minus x plus 2y minus 3z is equal to minus 9. And then I'm going to, if you notice the y's here, we have a negative 2y and a plus 2y, so I'm going to add these two equations. I'll put a big plus sign here. Add these two equations. I get minus 6, that's minus 7x. These are eliminated. Then I get minus 2, minus 3, that's a minus 5z. And then I get minus 28, and minus 9 is a minus 37, I think. That's step number 1, right? Step number 1, I used two equations to eliminate a variable. What I eliminated was the y. Now, in step number 2, I have to use this third equation. So I have 5x minus y plus 5z is equal to 30. And I have to eliminate the same. Last time I eliminated the y, so this time I have to eliminate the y. So if you notice, I can add that to equation number 1. If I add those two, right, this is equation number 3, and this is equation number 1. If I add those two, the y's cancel. So I get 8x, and then plus 6z is equal to 44. That's step number 2. Notice that I used, in the first step I used equations 1 and 2. In the second step I had to use number 3, and then it didn't matter which other equation. I have to use all three equations. Use two equations, eliminate a variable. Use two equations, eliminate the same variable. But you have to use all three equations. Now I'm going to write down the answers from step 1 and 2. Minus 7x minus 5z is equal to minus 37. 8x plus 6z is equal to 44. I'm getting some big numbers, so luckily I have a calculator. But what I'm going to do now is I have just a system of two equations and two unknowns. So I simply solve this. I can solve this any way you want to. I'm going to use the elimination method again. I'm going to multiply this one by a 6 and this one by a 5. Then I get minus 42x minus 30z. Let me do 37 times 6 on my calculator. 37 times 6 is 222, and that's a minus 222. Then that's 40x, 30z. 44 times 5, I think I know what that is, but I'm going to check it out. It's 220. Make sure I get the signs right. Positive, 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 that's right. And now what I'm going to do is I'm going to either add or subtract. Let's see what I'm going to do here. I want to eliminate the z, so I'm going to add these two. Minus 42 and 40 is 2x, actually a minus 2x. Minus 30 plus 30 is 0, and minus 222 plus 220 is going to be a minus 2. I divide by minus 2 and I get x is equal to 1. I plug this into either one of the original problems here. Not the very original, but one of these two equations. It doesn't matter which one. I'm going to plug it into the first one there. Minus 7x minus 5 times z is equal to minus 37. Plug in a 1 there. That's minus 7 times 1 minus 5 times z. Go to minus 37. I'm going to add 7 to both sides, and I get minus 5z is equal to a minus 30, so z is equal to 6. So if you notice, x is equal to 1 and z is equal to 6. Now let's check to see where we are on our steps. First, use two equations to eliminate a variable. Second, use two equations to eliminate the same variable. If you notice, I did that. I took two equations, eliminated the y. Two equations, eliminated the y. I have to use all three equations in the first two steps. Then I write down my answers from 1 and 2. If I write down my answers from 1 and 2, that's right there. If you notice, I have a system of linear equations with two unknowns. So I simply solve that using the elimination method, and I get x and z. So the third step is I use these answers from step number 3 to plug in. Now, what do I plug it into? I can use any one of the original equations here. Doesn't matter which one. I'm going to use the very first one. So I'm at 3x plus y plus z is equal to 14. I know that x is 1, so that's 3 times 1 plus y plus 6 is equal to 14. Give myself a little bit more space. That's 3 plus 6, that's 9 plus y is 14. Or y is equal to minus 9, y is equal to 5. And there's my answer. My answer is x is equal to 1, y is equal to 5, and z is equal to 6. And the way you write that is always x, y, and z. And that's how you solve the system of linear equations with three equations and three unknowns. And here are your steps. Use two equations, eliminate a variable. Use two other equations, eliminate a variable. In the first two steps, you have to make sure that you use all three equations. Take your answers from 1 and 2, and you end up with a system of linear equations with two variables. That's what we ended up with here. Then simply solve, and you get two different answers. In this case, I got an answer for x and z. Then you take that and plug it into any one of the original equations and solve. Then you write your answers x, y, and z. So if you want to check your work, how do you check your work? You have 1, 5, and 6. You take the original problems here and you simply plug that into all three different equations. If it works for all the three different equations, then it's your answer. And that's how you solve a system of linear equations with three variables and three unknowns.